Hey, you guys tell me where we started before I go through period one. Period one did a great job of asking a ton of questions, which was good to hear. All right, so you guys at home, you guys here, I am going to do number 4 at the very end. That is the last proof I'm going to do, so please don't ask that. But everything else is fair game here. Here we go, Quincy, where are we going? Number 5. Okay, everybody, number 5. Good question. Okay, here we go. Number 5. I start writing down the givens. I start writing them down. Boom! What do I see? Midpoint, midpoint. Midpoint, midpoint. That means I'm about to take something and cut it in half. Meaning, what am I going to eventually use in my proof? Halves of equal quantities are equal. All right, so this is a halves of equal quantities are equal. Before you can write halves of equal quantities are equal, you need to tell me what are we taking half of here. So that's what I need from some of you right now. Here we go. Game time. I don't have my cheat sheet. Hopefully you guys know, huh? 13. Anybody know they're 13 before I get on my cheat sheet? Hi, Sophia. What are you going to take half of up here?
WY and ZX.
Good. I'm going to take half of WY and we're going to take half of ZX. And we got to call it something. Okay, what's that segment we're going to call it now? Remember, you look at the proof statement to figure that out. Look at the proof statement. All right, next up. Woo. Here we go. 5. 5. Here we go. What am I going to call half of WY? Who's 5? 5. Here we go. And what am I going to call half of WY? WA. Again, he knew WA instead of AY because WA was in the proof. And what are you calling half of ZX? ZA. Again, because it was in the proof statement. Definition of a midpoint. Everyone good? Okay, now, here's what the theorem says, word for word. Halves of 2 equals, because they gave me this was equal up here, halves of 2 equals have to be equal to each other. And that's how I end this. Halves of equal quantities are equal. Step 3. Done. Okay, midpoint, bisector, halves of equal quantities, kids. Next up, again, I'm doing number 4 at the end. Next up, Sophia.
I just had a question about number 5, saying that so when you say 1/2, when you're taking 1/2 of something,
Yep.
That is the definition of midpoint or bisector or whichever.
Correct, because that's how I know I'm going to take, midpoint says you take half of it, it's equal to one of the 2 parts.
And then the last part would be the halves of equal quantities, not substitution.
Correct, not substitution. Others? More questions. Let's go. More questions here. There should have been more here. Nothing at all. Let's go. Number 2, everyone. Take a look at number 2. Number 2 is very similar to the notes we took on Friday dealing with straight angles. Again, I just want to remind everyone in class, your unit test is a week from tomorrow, next Tuesday. You guys at home are fully remote a week from Wednesday. All right, please don't forget. I'm thinking about on Monday, because we don't have school, maybe sometime in the afternoon I'll hold a virtual review session. Okay, for you guys that are around and are interested on Monday. Okay. All right, here we go again. Speaking of the test, never do this on the test. You can do that on the homework if you want, but not on the test. All right, so the 2 angles that are congruent, AGD, this angle, and GHF. So those are the 2 angles I'm marking congruent. They also tell me I have straight angles. Perfect. Look at the proof statement now. DGH. Make sure you guys, the biggest problem you may have had with this is not the proof, it's the actual angles. Can you find these angles? All right, can you find them? DGH, I'm just going to put a little dot right there. There's DGH and GHE. I'll put a little dot right there. So how do I get those 2 congruent? Well, let me just highlight one of the straight angles right now. AGH. So everyone see that straight angle? I only highlighted part of it. I don't need the whole thing. But what can I do with that straight angle and this blue one, AGD, that I marked to get to DGH, the one I need? Here's a little hint. Okay, saving. There you go. Here you go. Ready? What can I do to AGD and that angle right there to get to angle DGH? What can I do to that angle, those two right there, and get to that one? Here we go. 17. Anybody know if they're 17? I hope. 17 here at home. Okay. Thanks for all your help. Try this again. Watch, they're probably absent. 17, here we go. Maeve, hi Maeve.
Hi.
What am I supposed to do with those two angles? You're just going to let me float out here? Subtract them, yes. Everyone agrees, subtract? All right, again, how many pairs do I need to subtract? 2, but I only gave you 1. So you needed to tell me that the straight angles were congruent here. Angle AGH was congruent to angle EHF. All straight angles are congruent. And then now you have 2 pairs of equal quantities and you show me what you're subtracting. So you would do angle AGH minus angle AGD is equal to the other straight angle EHF minus the other congruent angle GHF. Subtraction, substitution, we're done. Okay, so this was just a subtraction proof. Tomorrow I'll show you a different way how to do this. But for now, subtraction. Next, what else we have before we go over any of the work here? What else?
6.
6? Okay, everybody, 6. 6, okay. EF perpendicular to GH. Perpendicular tells me I should be putting what marking on my diagram? Here you go, 8. You know already. Go ahead, Ryan. What marking should I put on my diagram? A 90-degree angle where EF and GH meet, correct? So that's why I erased it, but there is a right angle on both sides here. Here and there. I got right angles. So that's why FGH was 90, HGI was 28. Okay, everybody good? Made a 90-degree angle. You will notice, and I expect to see this when I walk around or when I check it on Google Classroom later today. Why is it 90? You better have a little reason why you thought it was 90. Why was it 28? Better have a little reason why it was 28 because I asked you guys to justify your answer, which means write a little something next to it. And I'm going to do the same exact thing next week on your test. Any algebra problem, why? Write a little statement why. And while we're here, we might as well go over 7, 90, and 50. 90 and 50 for 7. And again, with the little statement, why you thought it was 90 and why you knew it was 50. Yep.
I did a little bit extra explaining when I showed my work.
That's fine. That's fine. I always say this, Quincy. You hold on. You can never write too much, but you can always write too little. Okay? Go ahead, Maeve.
Could you give an example of like what would be like the justify your answer for like HGI being 28?
Complementary angles add to 90.
Okay.
Right? Because HGI and the one I gave you that was 62, they're complementary because they form that right angle. So that would have been fine. 2 angle, right angles add to 90 degrees would be another one. Something that said, why did you do 90 minus 62? Okay, why wasn't it 90 plus 62? Something, you see what I mean, Maeve? Okay, I want to know why you did the calculation you did. Other questions? Yep.
I put my justification of that one angle, HDI. I put definition of perpendicular. I don't know if that's not enough explanation.
That's fine. You're getting to the fact that it's a right angle.
It's
That's
90, I
fine.
know that it's 90 and I'm just saying.
Yep, that's fine. Now, if all of a sudden you came out like definition of a bisector, I got a problem with that, right? Okay. Other questions before I go over everything else? Number 3, everyone, take a look at number 3. Okay, number 3 was subtraction. This was very similar to the one I did in class on Friday. I saw the perpendicular symbol here. So I knew right angles had to go here and here, okay, on my diagram. Before I said subtraction, you had a lot of steps you needed to put in. What do you know about 2 right angles? I know they add to 90. What did you learn on Friday about it? It's up there if you got to cheat, go ahead. What do you know about 2 right angles? They're always congruent. But I had you guys write in a little note on Friday that said, before you tell me they're congruent, you need to actually write down that they are right angles. What's the name of them? So in step 2, take a look. You should add angle TRQ and angle TSQ are right angles. You had to have that in before you said they were congruent. And the reason being, definition of perpendicular would have been fine. Perpendicular lines form right angles. And then in step 3, now you're telling me they're equal. TRQ congruent to TSQ. And this is the theorem I went over on Friday. All right angles are congruent. All right? And then subtraction, substitution. Good? I'm going to show you a new way to do that proof today. Yep. Everyone good on this one? All right, number 1, speaking of right angles being congruent, here you go, number 1. Again, we know the deal. Never do this. Yep. Okay, here we go. ACB is a right angle, and CD is perpendicular to AB. Tell me markings I could put on my diagram right now, based off. Thank you, Q. Give me some markings I could put on my diagram just based by that statement right there. Let's roll. 8, going back, Ryan. What markings can I put on my diagram?
Right angle.
Where? Name the angles.
ACB and
I got ACB, that was given, but what about between these two? Where can I put them? ADC, and I could also go
CD.
right there if I needed to, right? They're on both sides. Everyone's good there. Look at the givens right now. I mean, not the givens, excuse me, the proof statement. Ready? ACB. What did I mark on ACB? What did I mark here?
Right.
That's a right angle. What did I mark for ADC? A right angle. What do you know about 2 right angles? They're congruent. That's what I'm going to use here. Right angles are congruent. But I can't say that. Here's the reason why. ACB. Did I write in my statements that that was a right angle? Look at it. Look at it before you shake your head yes or no. ACB. Did I write that down in my statements that that was a right angle? It was given. It was given. Did I write down that ADC was a right angle? No. So that's got to go in your proof. Check it. Let's go. Make sure correct work's written down. Angle ADC is a right angle. How do we know it's a right angle? I'm going to be grilling you guys here. 17. Here we go, Maeve. How do I know that's a right angle? Angle ADC.
Definition of perpendicular.
Perfect. I could also write perpendicular lines form right angles. Either one works.
Mr. Carlin.
Yep, I'm listening. Go.
Will we get points taken off if we said that both ACB and ADC are right angles in our statements?
Well, the reason ACB is a right angle is different than why ADC is. ACB is a right angle because I gave you that. Versus ADC because I knew perpendicular lines form right angles. So the answer to that question would be yes, I would. Because they have two different reasons why they're right angles.
Okay.
Okay? Good question. Yep. Now that I know both of them are right angles, I now know both of them are congruent. And that's the theorem from Friday. All right angles are congruent. All right, everyone good there? 3 steps. All right, 4. Here we go, everybody. Buckle up with 4. 4, whoo! All right, 4 was a little bit of a different one, a little bit of a challenge one for 4. And this is the point we need to get at right now. If you got it correct, awesome. If you didn't, don't be ashamed. Okay, I didn't expect many people to get this fully correct. All right, here's why. AB congruent to DE, and I'm looking for this right up here as my proof statement. Okay, here's why I didn't expect many of you to get it right, because I brainwashed you. All right, you've been brainwashed by me. Here's what I'm talking about. You've been brainwashed that when you see that keyword right there, what are you guys always thinking? Halves of equal quantities are equal, but it wasn't a halves of equal quantities proof. Okay? So how am I going to know from now on when I see midpoint bisector if it's halves of equal quantities or not? Because this one was not a halves of equal quantities. Here's how you know. Let's get more detailed. Look at number 5, please, where we did use halves of equal quantities are equal. How many segments were being cut in half in number 5? How many segments were being cut in half in number 5? Go ahead. 2 segments. 2 angles being cut in half. That's when I use halves of equal quantities. All right? If 2 segments or 2 angles are getting cut in half. Let's go back to 4. How many segments are getting cut in half in number 4? C is the midpoint of BD. How many segments are going to be cut in half? Just 1. I can't use halves of equal quantities because it's got to be 2 things I cut in half. Everyone see the difference now? Everybody at home good? Halves of equal quantities, we need to cut 2 segments or 2 angles in half. Number 4, we're not doing that. But you could still use that C as the midpoint. I just didn't throw it up there for nothing. Every single given you use. So what else, other than you're cutting it in half, could you tell me about BD? C is the midpoint. Tell me something else other than I'm taking half of it. There's something else. You know what a midpoint does. Right? It's more than cutting it in half. Sophia, you think you got it?
Maybe BC equals CD.
Done. Done. Oh, midpoint. Not only does it cut a segment in half, it cuts it into 2 congruent parts. BC congruent to CD. Nice job back there. BC congruent to CD. Definition of a midpoint. I can still use it, and I plan on it. Now, hopefully, you recognize what type of proof this is. I hope. Kyla, here you go. What am I going to do to AB and BC to get to AC? What do I have to do to those 2 segments?
Add AB to BC and DE to CD and set them equal to each other.
Done. I love it. AB plus BC is the same as taking DE and adding CD. This is an addition proof now. And where did my second pair of equal quantities come from? Definition of a midpoint. Okay, and then you guys know substitution at the end. Okay, so we made a little bit more detail here. Okay, we have a little bit more detail going on. Questions? Because I know I have that last question to go over, the answers. Okay, here we go. Number 8. CFD is 12A plus 45. Find A so that those 2 are perpendicular. If they're perpendicular, what are they going to form? 11. Anthony, what are they going to form? CF and DF is going to form a? Right angle. So I'm going to take 12A plus 45 and set it equal to 90. Yes, you did get a decimal, honors kids. Welcome to honors. 3.75. Okay? All good there? And part B, okay, part B. Here you go. AFB. AFB is 8x minus 6. BFC is 14x plus 8. I want to make sure this forms a right angle. So add them up and set them equal to 90. Yep, on me.
Do you have to explain your answer for this one?
No, it was just for really 6 and 7. I wanted an explanation for. Okay. All right, everyone all good? You guys at home, clean up your work. If you want to submit it, submit it. You guys here, I'm going to walk around and check it real quick right now. All right, so you guys at home, clean up your homework right now. Make sure the right answer's there. If you have time, submit it on Classroom and get ready for day number 5. And we have everybody here in class. Here we go. Keep them numbered, correct. Got some work and explanations. Here we go. I'm ready here. Don't want to forget about you. Honors, honors. Thank you, guys. Good. One more. All right, good. Did I give you his test, by the way? Sorry, my fault. I know who you guys are. I don't know why you did that. All right, good news to start off today's notes. Good news. All the theorems and facts we've been going over. So basically, you guys that have been in my classroom, everything that I put over here on the board, I'm going to give you a sheet of paper with all those for next week's unit test. Okay? So all those reflexive, substitution, addition, right angles are congruent, straight angles are congruent, they'll all be on one sheet of paper. People are like, oh my God, that's great. That's just like we're cheating. You still have to know when to use them correctly in a proof, right? The only reason I give them out, to be honest with you, is so you get the wording right and the spelling right. That's the only reason why I give those to you on the test. All right, you still got to know when to use them correctly. All right, let's do this. Oh, you want more good news? Yeah, we got 4 of them going up on the board today. 4 of them. Fridays dealt with right angles and straight angles. Today, supplementary, complementary angles. Those are today's facts, dealing with supplementary and complementary. Quick review, you guys at home too. Supplementary adds to 180, complementary 90 degrees. Perfect. Let's look at this first proof we have up here on the board. Your givens are already written in. You're welcome. What vocabulary term do you guys see in the givens in number 1? What's the main vocabulary term up there? Main vocabulary term in the givens is the word complementary. So angles adding to 90, right? So I'm telling you 1 and x add to 90, they're complementary. 2 and x add to 90, they're complementary. So why are 1 and 2 congruent? Well, first thing you guys probably goes through your brain, and please don't copy this down, but goes through your brain. You probably read those 2 givens, and the first thing you would say would be 1 and 2 are complementary. Because you do some type of substitution? Maybe? All right. Hey! Substitution is only for things that are equal to each other. Okay? Things that are equal. So if I said 1 and x were equal and 2 and x were equal, then yes, you could say 1 and 2 are equal by substitution. But you can't use substitution with words like complementary and supplementary. See the difference? Substitution only works when things are equal to each other. Good? All right, so to show you how this first theorem works, I need a couple helpers here. Need a few helpers. 12. I just totally, where's my cheat sheet? 12, 12, 12. Anybody? 12? Lucas? Ready? All I need from you is a random angle measure for angle 1, please.
63.
60. Thank you. Good. I didn't want to do the math here. 60. What's angle X then? Remember, given angle 1 and angle X are complementary. So what's the value of angle X? 17. Here we go. Maeve, on fire today. What's the value? Whoa, sorry. Go ahead.
30.
30 degrees. What's angle 2? Here we go. What's angle 2? Remember, 2 and X are complementary. So what's angle 2? 22. Here we go. Hannah, what's angle 2?
60.
60. What do you guys know about angles 1 and 2? They're not complementary. They are equal, congruent. They are congruent to each other. What gives me the right to say that? It's this new theorem. Ready? Help me out here. Woo. Love this. Love this. You ready, Sean? Here we go.
Yes.
In the proof statement, give me one of the angles in the proof statement, Sean.
Angle 1 is 60.
No. I'm not using the numbers anymore. One of the angles in the proof statement was angle 1, correct?
Yeah,
Look back at the givens for me, Sean. What did I know about angle 1?
it was complementary with angle X.
Everyone hear that? What's the other angle in the proof statement, Sean?
2.
And what did I know about angle 2 in the givens?
Also complementary with X.
So you're telling me, Sean, and this is my last question, both angles 1 and 2 are complementary to what?
Angle X.
The same angle. Everyone see that? 1 and 2 are complementary to the same angle. So if I have two angles that are complementary to the same angle, they have to be congruent. That's how this first one works. Everyone see that? Two angles, 1 and 2, complementary to the same angle, angle X, are equal. Good? All right. So all this is going to be is a two-step proof. We're going to say angle 1 congruent to... Oh, forgot something. Hold on, forgot something. Forgot to write down a little note up here. Hey, quick question. Actually, I'm going to ask somebody this question. Woo, 23, go home. Luke, here we go. Were you here on Friday, Luke, to take the notes?
Yeah.
Okay, I talked about all right angles being congruent, and I said to everybody in class, I said, hey, if you're going to tell me right angles are congruent, what do you need in your statements first, Luke? Do you remember?
I don't remember.
Anybody help him out? What do I need in the statements before I say right angles are congruent? You need to tell me, Vinny,
That there are right angles.
where the right angles are. Everyone remember that? You need to tell me what the right angles are. Same thing here. Before you use any complementary theorems, guess what's got to be in your statements? What angles are complementary, all right? So in your statements, need which angles are complementary first? Okay? Before you use any of these theorems. So does that mean in step 2, I need to tell you what angles are complementary? Why don't I need to tell you in step 2 what angles are complementary? Here we go. Omni, hello? Why don't I need to tell you in step 2 which angles are complementary before I use this? It's given. That's it. It's given. Okay? It's given. If it wasn't given, I'd write it down. All right? So angle 1 congruent to angle 2. Here's the new theorem. Complements. There's no I in complements. Have some self-respect. Okay? There's no I in the word complement. No letter I in the word complements. Okay? It's an E. Complements of the same angle are congruent. Last time, what were 1 and 2 complementary to? The same angle. Yes? We're all good there? Whew. All right, almost had a brain freeze. All right, one doesn't make you great. Let's keep going on to the next one here. You guys have it already filled out. All you need to do is mark your diagram for me, please. Mark your diagram. Go ahead. I got perpendicular and I got congruent angles. Go ahead and mark your diagrams. While you're doing that, let me know what you're marking your diagram with. Here you go, 22. Hannah, what are you marking your diagram with?
Sorry, I couldn't unmute my mic.
It's all right. What markings are you putting on your diagram, Hannah?
You're gonna do not an arc. Oh, an arc mark.
Yep, at FBE and EBD, right, to show they're congruent?
Yeah.
And then what about this perpendicular business? What can I put on my diagram there?
A square to show that they're 90 degrees.
Name the 2 angles I can put that square on.
ABE.
Yep, and good job. So everyone go with my markings. Please look at the 2 angles I need to prove congruent now. Find them, find them. Find the 2 angles I need to prove congruent. ABF, I'll just put ... right there. And DBC, ... right there. Okay? Guys, over the weekend, if I gave you this, you could do this no problem. Anybody know what I could do here to get those 2 angles equal? Don't even use complementary or anything. You don't need it. What could I do here? What do you think, Quincy?
You could use the definition of perpendicular angles to get 90 degrees for both of them and subtract.
Subtract. This is subtraction. I could do subtraction here. Everyone see the subtraction I could do? Say the right angles are equal. Subtract, substitute. All right, but I'm going to do this a different way. Okay? I'm going to do this a different way. 18. Let's roll. Here we go. Owen, question. EBF. Do you see that angle, Owen? EBF.
Yes.
And FBA. Do you see that angle?
Yeah.
What do they add up to?
90 degrees.
90 degrees. Give me a big boy word for 2 angles that add up to 90.
They're complementary.
Everyone, yes? Yes? Those 2 are complementary. And what about on the other side, Owen? These 2 right here, EBD and DBC. They are also what?
Complementary.
Good. They're both complementary. Now, let's go back to the angles I need to prove congruent. Ready? Are these 2 angles complementary to the same angle or to 2 congruent angles? One more time. Are these 2 angles complementary to the same angle like there was in example 1, or are they complementary to congruent angles? Congruent angles. Now we're about to use, where are you? The second one. Everyone see the difference? Complements of congruent angles are congruent versus being complementary to the same angle. Everyone see that? Okay? But I'm missing something. What was the note you wrote down? If you're going to use a complementary fact, you need to tell me which angles are. All right, let's do it. What angles are complementary? Owen already did it, but I need somebody else to make sure we're following along. Gideon, here we go. Name me 2 angles that are complementary.
EBA and EBC.
EBA is the right angle. Well, those are the right angles.
Oh, sorry. EBA and EBF.
EBA is the right angle. Come on, one job here.
Okay. EBF and FBA.
Good. I had you rattled there for a second. Nice job. EBF and angle FBA are complementary. And there's another pair up here. Another pair. I got to write that pair down too. Ooh, 19. Sean, give me the other pair.
EBC and EBD.
EBC?
Yeah.
That's
Wait,
a
no,
that's a right angle.
DBC and EBD.
Okay. EBD and angle DBC are complementary. Okay, let's talk reason. pretty flexible here. Just drop some knowledge on me right now. How do I know those pairs are complementary? And again, I'll take anything here. I'm not looking for a precise definition here. Why are those pairs complementary? Let's go. Why are they complementary? Just tell me in your own words. Oh, 5. Hayden, why? In your own words, why are those pairs complementary?
Because they both add up to 90 degrees.
Okay, complementary angles add to 90. Fine with me. The only thing I would not want and would not accept is definition of complementary. I think I've done this before. You guys are sitting in a chair. How do you know you're sitting in a chair? Definition of a chair, Mr. Carlino. That doesn't tell me you know what a chair is. Okay, so don't use definition of complementary there. Now, after you've told me they're complementary, now we can finish this proof and say those complements, ABF and DBC, are congruent. Complements of what were they complements of? The same angle or congruent angles? Congruent. Complements of congruent angles are congruent. That's what you guys need to do tonight on your homework. I'm not done yet. That's what you need to do. You need to take a look at the angles you're trying to prove congruent and say, are they complementary to the same angle like they were in problem 1, or are they complementary to 2 congruent angles? That'll make the decision easier on which one to use. Okay, Sophia, go ahead.
What's the explanation for the second part of number 2? It says, we said complementary angles at 90 degrees.
Yep.
You don't need to put that they are 90 degrees.
You could, that's fine. That's an extra step that is still correct if you wanted to do that. I see where you're going there. That's fine. Okay, and then finally, before we end this, these 2 complementary ones, take complementary out and substitute in supplementary. It's the same exact one. Okay, same exact things. Okay, tonight, heads up, I snuck in an addition subtraction proof tonight. Heads up. Okay? All right. I'll be after school all week today if you want to pop in on the Google Meet. You guys at home, have a great day. You guys here, behave. Statements reasons. So those here, they're not, all I want you to do is the algebra. Okay? So you don't need to set up a statements reasons column. Have a good one, guys.
One of these days, I'm just gonna watch one on my social media. I don't know what he talks to about this. Checkmate. You can always like get a bigger bag. That's a poncho. Why do you have a poncho? In case it rains. That's dumb. Bring an umbrella. It's dumb to have protection in case it rains.